Assalamualaikum warahmatullahi wabarakatuh. Today we'll be looking at gas laws. Okay, there are 3 laws, but first let's look at Boyle's law. Okay, for this topic we will look at pressure, temperature and volume of gas. Now look at this picture here. I'm sure every one of you have seen this, especially for those of you who always buy things online. Okay, let's say you beli apa maybe beli, I don't know, computer ke laptop, gadget, anything lah, which is very fragile. Okay, and of bubbles kan, bubbles wrap. So this is an air cushion wrap, okay, usually used in packaging of goods, or maybe you buy biscuits ke kan. When it is compressed, the air inside gives resistance. Look at that kan, bila dia tekan nampak macam ada bahagian lain yang membesar, bahagian yang ditekan tu mengecil. So this observation can be explained in terms of the behavior of gas molecules based on the kinetic theory of gas. We will observe the behavior of gas molecules. So while you watch the simulation, think about the movement of gas molecules. And then look at the space filled by gas molecules. Look at the spacing. And observe the direction of motion of the molecules. How do you describe the movement of gas molecules? There is heat. So look at the movement of the molecules. Now compare that with if we remove the heat. Now look at the movement. Okay. So maybe we can talk about the kinetic energy. And then how about the space filled by gas molecules? Okay, we have learned last time. Okay, gas molecules, they are far apart from each other. So they occupy a large space. And then, can you tell in which direction a molecule will move once collide? So we cannot predict, right, the direction. So the direction is random. Okay. And did you notice collisions between gas molecules and the walls of container? Yes. And that collision, the collision between the gas molecules and the walls, causes pressure. Pressure, temperature and volume of gas in a closed container based on the kinetic theory of gas. Okay, so now we look at characteristic of gas and the description of it. So first is pressure. So for pressure, gas molecules always move randomly. And then when gas molecules collide with the wall of the container and rebound, a force is exerted on the wall of the container. So force per unit area is the pressure of the gas. And then we look at the temperature. Average kinetic energy of gas molecules increases with temperature. And gas molecules move freely and fill the entire space of the container. Volume of gas is the same as the volume of its container. SI unit and other units for pressure, temperature and volume of gas. So pressure, the symbol for pressure is P. So ini yang selalu pelajar tersilap ataupun confused. P is not the unit. P is a symbol. Symbol for what? Symbol for physical quantity pressure. Pressure is a physical quantity. Quantity fizik. Dia boleh diukur kan pressure tu. Okay, and then the SI unit for pressure is Pascal. And the symbol for Pascal is PA. And then for pressure, okay, you will see, silap ni. So for pressure, we can have other units for pressure, okay, other than Pascal, which is centimeter Hg, or sometimes millimeter Hg, sometimes mHg, meter Hg. Okay, depends on the situation and depends on the instrument. And then we have a second quantity, which is temperature. The symbol is T. The SI unit is Kelvin. And the symbol for that SI unit is K. Okay, another typo here. So remember, when you want to spell the unit, you must always use small letter. Okay, you cannot use capital letter because this is not a name. And then the symbol for Kelvin, of course, K, and other units, I'm sure you know, degree Celsius, degree Fahrenheit. And the last quantity is volume, which is V. Okay, the unit is meter cubic, m to the power of 3, and other units meter cubic, centimeter cubic, or maybe milliliters. Look at this diagram. So this is an exercise ball. The exercise ball is being compressed by this boy. What happens to the air pressure inside the ball? Let's carry out an experiment to explore and find out the relationship between pressure and volume of gas. Okay, the inference is volume of gas influences pressure of gas. Okay, or we can say volume of gas is affected by the pressure of gas. What's the hypothesis? Yes, the smaller the volume of gas, the higher the gas pressure. That is what you guess. And then for this experiment, because we want to look at the relationship between volume and pressure, one of them must be the manipulated variable. So we choose now volume as the manipulated variable. Therefore, pressure will be the responding variable. So there are three important physical quantity we are looking at in this topic, which is pressure, volume, and temperature. Since we have used volume and pressure, they are the manipulated and responding variables. Therefore, temperature must be the constant variable. And another one is mass of the air must be fixed. Now, look at this experiment. So this is experiment Boyle's law. Okay, this is an experiment, virtual experiment. So we set the manipulated variables. So we need to have at least 5 data. Okay, so for this virtual experiment, I have more than 5 data. But if you are in the lab, it is necessary, if you have 5 data, that is good enough. We push or pull the piston so that the volume increases or decreases. Okay. When you have all the data, so you can plot the graph. Okay. So this is the graph that you get. So what do you see from the graph? So volume is our manipulated variable. Okay, so look at the table here. So this is our MV. But if this is your report, okay, you must include the unit here, which is for this experiment is in liters. Okay, and this pressure is the responding variable. Okay, for this experiment, the unit is ATM, atmosphere. Okay, units. Okay, so you can ignore the third and fourth column. Now, from the experiment, we obtain this graph. Okay, so we plot the data from the table, from the observation. So from the data, we get this curve graph. So the curve graph is a graph of inverse graph. So we say the relationship between pressure and volume is, yes, pressure is inversely proportional to the volume. Okay, maksudnya that means when volume increases, look at that, when volume is high, what is the respective pressure? Pressure rendah, decrease. Okay. Now we can use this data and plot another graph, which is graph 1 over V. So how is the graph different? How is that differ? So this is the pressure against 1 over volume, 1 over liter. So from this graph, okay, after we plot, okay, so those are the plots. So we get a straight line graph. It's totally different from what we have got just now. So just now we had, so P, this one. Now we have this. But we are doing the same experiment. So what is happening? So actually we just change the variable ni from V becomes to 1 over V. So from that we still have relationship P directly proportional to 1 over V. Just now I told you pressure is inversely proportional to V. Okay, I only mentioned about V. Okay, but they are the same. Okay, it's just the way of you writing it, the way you plot the graph is different. Okay, now what conclusion can you make from this experiment? So the conclusion is gas pressure increases when the volume of gas decreases. So we see from the graph, pressure of gas is inversely proportional to the volume of gas at a constant temperature. Temperature must be constant. Okay, and this graph also is equal to this graph. Okay. For a fixed mass of gas, pressure is inversely proportional to volume. So you have seen that one. So tak susah lah, tak perlu nak hafal. You need to understand what you have seen, what we have discussed just now. Okay, so that is Boyle's law statement. Okay, so from that statement, from the experiment, okay, we know the relationship between P and V, which is inversely proportional. So you need to know P is in Pascal. So P is the pressure, V is the volume in meter cubic. And we have K. So how do we write K? So you learn in mathematics when you want to change the symbol of relationship to equation. So you need to add K, and K is a constant. Therefore, we get an equation P times V equals to K. Now, if we have two conditions, kita ada condition 1, condition 2 ataupun condition sebelum ataupun selepas. Okay, so since P times V equals to K, so during condition 1, we have P1 V1 equals to K. At condition 2, we have P2 V2 equals to K. So since they are K and K, they are the same. Therefore, we can equate them. P1 V1 equal to P2 V2 because they are equal to K. Right? So we don't need to write K because they are equal. Hence, okay, we get this equation in Boyle's law. Okay, so this is not difficult. Figure shows a fixed mass of gas compressed at constant temperature. Then you look at the two videos. Okay, when the volume gas decreases, when you push the piston, so the volume decreases, but the number of molecules is still the same. However, the space is smaller. So when the space is smaller, okay, this causes the rate of collision increases. Therefore, the pressure increases. Look at the value of the pressure. Okay, so the pressure increases. Okay, I want to introduce you to the smart triangle. So you write P for pressure, then V for volume, and T for temperature. So for this experiment, we look at the relationship between pressure and physical quantity volume. So they are next to each other. So the formula is P times V. Okay. Now, so and then you need to know P1. We have this when we have two conditions. Right, so this is, how do you remember? So this is the way I remember. So this one for BPV, BP. Dulu kita ada British Petroleum in Malaysia. Dah sekarang dah tak ada. Dan kita panggil dia BP. So that's how I remember lah. So BPV. So we have British Petroleum. So that's for Boyle's law. So Boyle's law is PV. So for Boyle's law, P next to V, and temperature is the physical quantity that we must keep constant. So this is what is kept constant, right? So kalau kita tutupkan ni, so the formula is PV. But this is the formula. The relationship is terbalik, opposite. Okay, so dia punya formula P darab V, tapi relationship dia adalah P is inversely proportional to V. Kalau relationship dia turun bawah, tapi kalau tak, kalau formula dia sebelah-sebelah. Okay, alright, that's all for now untuk Boyle's law. Next we will look at Charles and Precious law. Okay, so to check your understanding of what you have learned today, just now, so click the link below to answer short quiz.